Hello everybody, how are you today? Good. We continue the debate about the connected car, the self-driving car, and as you know, during those days we are talking and thinking how we will include all the technologies in order to connect not only our car, also all the services and business models that we will have around that. Now we have a discussion panel talking about connecting vehicles everywhere, because one of the challenges that we have is how can we connect our vehicle, our car, with other cars and with the car with the infrastructure. At the end of the day, we have a lot of technologies, but the challenge is how we will work. It's ready, the infrastructure, are ready the cars. If I have a connected car and I have to make a dialogue with a car that is not connected, this is a no dialogue. It means that we have a transition, we have an evolution, and we have opportunities to develop pilots in real places where we can control the infrastructures and the car, and we have spaces or moments where we will implement, for instance, in highways or some special places where we will develop all of that. For this reason, let me introduce Pilar Bernat. She will be the moderator of this session, and let me offer you to introduce your speakers. Thank you.
Thank you very much. Good morning, ladies and gentlemen. It's a pleasure for me to be here at the FIRA of Barcelona, attending the Autonomous Congress, and more precisely, the Connected Hub. The title of this session is Connecting Car Everywhere. An engineer would say B2X, the B2X conference. And what a better place to talk about it than a room named Inspiration Arena. It's fantastic. I suppose that we are going to have fantastic things here today. Probably you are asking yourself why a woman like me, so nice, so young, is here talking about this item. But I'm going to explain you something. I am a journalist, and I've been writing about semiconductors, connectivity, etc. Since 1999. And I've been testing cars from the beginning, and it's strange because I know that I do not look to be a freaky girl, but well, I try to know everything about this kind of items, and of course, I'm going to learn a lot today. Believe me, I think that we never dreamed that we are going to have a world like the one that we are building in this moment. Probably we have here a lot of young people, but for people like me and probably for us, it's impossible to understand that we are going to have autonomous car or connected car everywhere. It's difficult. I talk with my daughter, with my son, and I know that the young people can understand it better than me, but it's also difficult. Everybody is talking about connected cars, and not only cars, but motorcycles, trucks, military trucks that are being connected or are going to be connected. Everybody's waiting for the 5G, like a child in a Christmas night, but we have to wait a little bit, and in the meantime, we have to see another kind of technologies. And we are going to talk about that kind of technologies that are being implemented today. I think that the companies are in their marks, okay, because the competition is about to begin. The world is waiting for all that companies and all that professionals that are working on it. The industry have to bring safe and efficient connectivity to our cars, but we also want a full world of entertainment inside the cars, communications and services for the driver and for the passengers. But let me tell you something. Furthermore than being a journalist writing about that items, I am a teacher. I am a teacher at the university. And as you can imagine, I need to learn. I need to listen, I need to read, and of course, it's a great opportunity for me to be here with that kind of professor like the ones that we have here, then I think it's better to listen them than to listen me. Then let me introduce you Gregory Ewert, okay, from Inmarsat. Is the president of Connected Car and Intelligent Transport of Inmarsat. As you know, it's a satellite company. And he's in the board of governors of the Connected Vehicle Trade Association. Inmarsat used to be where nobody is. They offered coverage in those places where operators do not deploy infrastructure. Today, Inmarsat is the market leader in provision of mobile satellite services. They have a business unit specialized in machine-to-machine communication, and as we can see, and you are going to see, now are involved in the connected car and intelligent transport. I'm going to give you a quote from Greg, if he doesn't mind. Greg considered Inmarsat is able to deliver real-time global coverage, reliability, and security that today's connected vehicle ecosystems demands. Welcome, Greg. ¿Vas a empezar?
Yeah.
Okay.
Yeah.
¿Luego os presento a vosotros?
Thank you very much. I appreciate that. Well, it is an exciting time to be involved in a connected car, autonomous car, etc. I think we're seeing a tremendous influx in different technologies. The auto industry is now entering the digital stages of its life, which we're finding is opening up a lot of different opportunities for the marketplace. I'm going to walk you through a couple slides here that'll explain a little about that as we go through. It's a $1 trillion industry, and I would even argue that it's a multi-trillion dollar industry when you look at the entire eco-structure that is around the automotive industry. But again, as I said, it is going from a change of being a manufacturing company, a company that used to make hardware, to a company that's going to be service-oriented on mobility. A company like Ford, you will find in the next few years, will have a portfolio that includes everything from a traditional vehicle, shared bus services, they will have shared car riding services, and I would even argue that they will go down into motorcycles and bicycles. So they will cover the full range of mobility, getting from people from point A to point B in a different environment that I think, as we've talked about already, is going to radically change the makeup of transportation in the world. So why we're excited about this, if we look at today's connected vehicles, and we'll talk a little more about the difference between connected vehicles and autonomous vehicles, there are about 140 million vehicles by the end of next year that will be connected around the world. When I talk about connectivity, connectivity comes in multiple fronts, and we will talk about the differences of vehicle-to-vehicle technology, vehicle-to-infrastructure technology. There's LiDAR systems, radar systems, camera systems, LTE systems, satellite radio. There's a lot of things from a communication standpoint going on in the vehicle today, and there will be more so in the years to come. As this demonstrates here, by the time we get to 2025, almost every vehicle coming off the production line will have connectivity and will need to function in society connectivity. There are about 100 million vehicles that are produced on an annual basis, and I can assure you that all those vehicles will be connected in the years to come. So one of the things that we look at when we talk about connectivity is, because connectivity is going to be so important, we need to look at an ecostructure of networks. So when you hear the word connectivity, don't necessarily think of connectivity from the standpoint of cellular, satellite, vehicle to vehicle. It's going to be a combination of all of these. A combination of all these fused together to provide the vehicle and the passenger in the vehicle what they need to do in society on a go-forward basis. You're going to see the vehicle or the platform of the vehicle with a complete entertainment system in it that will mimic what you see at your home or your office. But on top of that, there also has to be an autonomous vehicle that is taking you from point A to point B in a very sequenced event. There's an industrial IoT component to making sure that vehicle runs, it gets from point A to point B, that's going to be as important, or if not as important, as the entertainment systems or the consumer element that you have in the back of the vehicle from that standpoint. So again, network of networks will be very important from this standpoint. One of the things that we bring and we think is really interesting is on being able to provide information on a global basis. One thing that satellite does very well is it has a unique broadcast capability. So when you're thinking about updates needed to be done for vehicles, and an update can be something as simple as providing a new algorithm for the heating elements of a seat. It could be as critical as a security key that needs to be reestablished in vehicles because vehicles have been hacked. Being able to get that vehicle efficiently and quickly is going to be very important, and that's where a highly scalable broadcast network comes into play. You can think in the years to come of today you take your vehicle into the auto shop to be repaired. In the not too distant future, over-the-air updates will command what used to be a visit to an auto shop. While you're sleeping, while your car is at a parking lot, while you're driving to the office, or while this autonomous vehicle is going from point A to point B, there will be continuous data being dumped down to that vehicle. That will be updating its mapping systems, it'll be updating its critical component systems, and it'll be providing the entertainment and other things that come with the vehicle also. So the user cases that we look at from our standpoint in this environment, I think I explained just recently the over-the-air updates. We were remarking a little while ago, you can think at some point in time, today when we look at a vehicle, it's got 100 million lines of code in it. It's a rolling computer. I would even go as far as to say it's a rolling data center. With the fusion of technology and the sensors that are on vehicles today and in the future, it will be consuming data and spitting data out at an unbelievable terabit type speeds sequence. So being able to not have to bring a vehicle in to be serviced to get all these additives done to it is going to be important. Another thing is going to be the enhanced navigation. We all know that we have navigation systems on our handsets and our phones. It's one thing to know where you are relative to a street. It's another thing when we're going to have cars doing the driving for us that we have to understand pinpoint accuracy. So again, enhanced navigation services through the offering that we have, and again, being able to provide a ubiquitous coverage and safe coverage of that enhanced navigation system is going to be very critical also. GNSS augmentation, that has to do with your GPS systems around the world. Again, the fusion of all this technology is going to be important to pull together so that we can get more pinpoint accuracy of where we are, where we need to be, etc. Managed security systems, as I talked about too. Critical that we're going to be able to get keys authentication. It's not a matter of if a car is going to get hacked, it's a matter of how responsive you can be to that hack. And again, using some broadcast networks in conjunction with other networks allow us to be able to put the patches and the security codes back in split seconds rather than making events turn into nefarious acts. And also general telematics. Telematics is just the maintenance of the vehicle, knowing when it's doing predictive maintenance, knowing that and sending messages to and from that tell it where it needs to be, and also tell it what it needs to do. You could find that there's engine components or battery components that show significant wear and tear through big data analytics. Being able to get that off and be able to do predictive maintenance will make the driving experience and the user experience all the more better because the car will not break down because someone will fix it before it breaks down. So one device global reach, this is at the Consumer Electronics Show earlier in the year, we demonstrated this technology. We have a partnership with Continental. Continental is the #2, what's called Tier 2 provider, providing everything from tires to electronics to vehicles. We've showcased that in the traditional antenna fin that you see on a car, we're able to, in that intelligent antenna, put different elements of RF signaling. And when I say RF signaling, that would include everything from a satellite receiver to GPS receivers, satellite radio receivers, Wi-Fi receivers. That's going to be the intelligent antenna that's going to be able to take these network of networks in. Embedded in the TCU of the vehicle, which is a router of the vehicle. We will have our chipset embedded in there that will allow the intelligence of this all to work. Again, this will be done seamlessly in concert behind the scene, taking into consideration satellite networks, cellular networks, Wi-Fi networks, LoRa-type networks, etc. So the benefits that we see, again, as I'm wrapping up here, lower price, being able to get to one vehicle anywhere. You can see a vehicle rolling off a production line in Stuttgart or in Detroit. Tomorrow it can be in Shanghai, or it can be in Chicago, or it can be in London, and the auto manufacturer will be able to have connectivity with it. They will be able to update it when it's en route to its final destination. This is revolutionary with respect to how cars are not only manufactured, but how they're maintained on a go-forward basis. We operate, the only single global world network. That's important from this standpoint, and being able to fuse and merge in other terrestrial networks will allow this benefit to be utilized by the auto industry. Reliability that I talked about, 99.99. That is unheard of in the traditional telecom environment. We're able to provide that with the redundancy and the resiliency that we have built into our network. And again, when we think about making a phone call, having a fast, busy signal, and a vehicle using that same communications channel that's driving us from point A to point B, we can't have fast, busy signals. Highly secure. Our networks run on a private VPN. It does not cross the public VPN network. That is going to add layers of resiliency with respect to cybersecurity also. And again, as I said here, it's the security and the resiliency with respect to the network itself that makes it so important. So in concluding, I think global mobility, security and safety are going to be the key factors that we look at. Again, this is not about one company being able to do anything. This is about a new ecosystem that's being formed around the auto industry, and the auto industry which is moving from a manufacturing standpoint to a service standpoint and a mobility standpoint that is going to be truly revolutionized and a lot of fun for us all to participate in. So with that, I thank you, and I'll pass back off.
Thank you, Greg. I'm going to ask you to prepare your questions, because I'm sure that you are not going to have many opportunities to have better answers because you are not going to be every day with all that kind of panelists. Please ask Greg about platooning. Can you imagine the highway without a truck disturbing you? That could be fantastic, and he knows everything about it. Okay, now let me introduce you Joan Palacín from FICOSA. FICOSA, as you probably know, because it's a very well-known company in Spain, is an automotive company. Automotive is one of the new words that we all love. He's focused on the creation of high technology safety, efficiency, and connectivity solutions for the motor and mobility sector. John considers that in an environment like the one that we are living or we are working on today, it's very important to find good partners to develop good products, as they have done, for example, with Panasonic. Probably you have here, if you came to the Mobile World Congress, probably you had the opportunity to have the opportunity to work with them or to see the solution that they are developing with Panasonic. FICOSA is also involved in the startup world. They are working with a lot of startups here in the event. They are working with Telefonía in the 4th year from now. And if you have questions about it, probably John is going to answer you. Please.
Hello, good morning everyone. It's a pleasure for me being here with you. So in this forum of connected vehicles everywhere, I would like to talk about the main pillars of what means autonomous driving and connectivity. So just a big overview of the company. Probably you know FICOSA. We are a tier 1 automotive company, 10,000 people worldwide, 1,000 engineers developing all these kind of solutions. So the main vectors of growth are three in the sector and also in our company. So first we have safety and vision, growth vector, then efficiency. Efficiency means lowering consumption of the cars, green cars, electromobility, and finally connectivity, which is the business unit I'm representing today. So what is autonomous driving? Is something new. Everybody talks about that, but it's not really new. In fact, when this visionary of the automotive was making this drawing, I was not even born. So it was in 1974, but the concept of autonomous driving is very, very clear here. It means cars talk to infrastructures, and people is not looking at the road. The interesting thing is inside the car, it's not in the road. It's enjoying the way, it's having time, it's talking with the family. There was no YouTube, no Instagram at the time, but there is something on a screen, so they are watching something. So this is the main concept of autonomous driving, and this is where we are going. Not a new idea, but a big challenge to overcome. So what do we need? Which are the main pillars of autonomous driving? So we see mainly 4 pillars. Pillar number 1 is the ADAS, all the technologies of around the car and vision technology. So this is like a person. An autonomous car should be like a person. You need eyes, you need ears, you need to, not to speak, but you need to communicate outside and inside. So which are the technologies that will be the sensors of the car to allow autonomous driving? So ADAS is one of the key technology. The GNSS, as Greg was commenting, the satellite positioning system. So we need to know exactly where a car is and where all the objects around the car are. The third pillar is connectivity, cellular connectivity, so mobile phones, networks, 3G, 4G. So this is a basic for autonomous driving. And the fourth is V2X that we are talking today. It's cars talking directly to other cars, to infrastructure, to pedestrians. So cars need to talk with people around the streets. So going one by one, I'm going to make a focus on each one of the pillars. So first one, regarding ADAS technology, it's all the range of sensors that are around the car. So you have mid-range radars, ultrasound, top view. So this is a key technology that we are also working on. It's not the object today, but it's important and one of the main topics that it's fully developing and going to a 3D, 360 degrees recognition. So you need to understand exactly what is surrounding you in a high precision manner. So the second of the pillars is the GNSS, so Global Navigation Satellite Systems. So in this field, FICOSA is leading one European project called SCAPE. This project is also participated by Renault, GMB, STMicro, key partners, and the main goal is to work on the safety critical applications of the positioning. Because I'm gonna make you an example. Half a meter positioning precision is the difference between being dead or alive when there is an autonomous car in a street, and is the difference between a pedestrian being inside the road or outside the road. So the car needs to decide and to understand if this person is inside or outside the road, because otherwise he will stop. And in a street crowded of people, an autonomous car cannot go if cannot play with this information. So positioning is key for an autonomous car. Sorry. Then we need reliable information, because if you cannot trust all the sensors that you have and all the information you are receiving, you cannot take the right decisions. So is this a bicycle? Is this not a bicycle? Is this moving? Is this a stop? So one of the important points is reliability on the data you are receiving. And then we also work on this program to deploy and to promote the Galileo satellite systems. You know, it's the European satellite system, so all this program is focused on European satellite systems. So as I already mentioned, so the main objectives of this program is develop a positioning engine for safety critical applications, so the GNS European network, and focused mainly on autonomous driving. So that's why we are counting on a Renault-Nissan partnership to develop and to validate all these solutions through a key OEM, a car manufacturer. The third pillar is the connectivity. Connectivity, so this is a graph of the new cars. So now in automotive industry, it's building 90 million cars, so going to 100 million new cars every year. So here you have the penetration range of connected cars. So last year we were about 27-30% of new cars are connected, embedded connectivity, and we are going to big numbers, 60, 70, 80% of connected cars. So it's a reality today, and it's increasing. You can see by region. So US is the leading region. So that the consumers, the drivers demand connectivity. So you cannot not think on a car that is not connected anymore. Europe is a different pattern. Europe is more driven by regulation. The eCall regulation. So all new cars from 2018 will need to be equipped with eCall, a system that is automatically calling the emergency service when you have an accident. Then Japan is still today focused more on infotainment and connectivity, but Toyota is driving the connectivity deployment in Japan. And finally, China with a big growth. It will be the second player in the world, the second market in connected cars. I think it's 2020. What about the technology? Everybody's talking about 5G, which is the big technology that is coming. But if you see 2017, today, we are saying goodbye to 2G in automotive. 3G is still the most important technology in mass production nowadays. The big growth goes on 4G. So we have 4G, 4G Advanced, so LTE Advanced, it's categories 3, 4, 6, 9, 12, 16. So there is still a big room for 4G before 5G is coming. You see 5G vision is 2021, 2022. It's quite close, but it's still time to be a reality in the cars. What about business? So if you see that connected car is the way to autonomous driving, but it's a business itself. So it's the biggest growing business case in automotive. So you see here safety applications. There is a business around safety applications. You see the connected services itself, also a business, but autonomous driving is the biggest growth factor in this sector. Nowadays, it's still a premium concept, so all premium brands are introducing, and let's say the mid-range and low entry segment, not that much, but it's growing. It's going to be massive. It's going to be transversal. So people that is buying a car, independent on the budget you have, you want a connected car. So you cannot afford a not connected car nowadays. And finally, the last pillar is the V2X, so car to everything. Cars will talk each other, cars will talk to infrastructure and to pedestrians, so it's one of the senses of a driver. So I'm going to put you some examples. So which are the starting applications of V2X? So car to car, you have approaching emergency vehicles, so you will know in advance that there is an emergency car, like an ambulance or police coming. You see that there is a danger in front, an accident, some issue, half kilometer or 1 kilometer before you are arriving. So it's a key safety application. And regarding infrastructure.While, so you will be advised that there are some work roads, somebody that has passed a street light, you will be advised, be careful, there is a crazy driver on the corner. So all sensors are fantastic, but they have a handicap. They cannot see through buildings. So if you are in a deep corner, you need to see through the building if there is a crazy car coming, and V2X allows you to do so. And finally, let me talk about also the infrastructures and the cities, the big influence on the cities. CDOT is a Colorado Department of Transportation program. This is a big program in United States of a smart city, a big funding program. Panasonic is leading this program. And the main targets of this program is to develop all the infrastructure and all the ecosystem needed to become a smart city and a smart state in the United States. Not only the city, but also the motorways. So there is a huge problem on congestion of infrastructure, cost of the infrastructure itself, and lives. So a lot of people dying on the roads, and we as a society, we cannot afford that. So this program is talking about connection, transport, commuting, safety, and integration. The main objectives are we have to reduce the crashes. We want to increase the capacity of the roads, otherwise they will be useless, so no way for a congested infrastructure. We need to improve reliability, so we need to know how long it will take our commutation to work. And it's the path to a new system of working, of living, of companies involved on this city and state connectivity program. Last slide from my side. Use cases and benefits of connectivity. So, as commented, we have safety alerts. It's very important to know what's ongoing around. Autonomous driving is the key, the main target at the end of the road. But we have also a lot of business cases on parking management, on traffic management. We have to optimize the infrastructure, so not just to spend money to increase it, make it more optimum. And finally, environmental challenge, which is pollution reduction through all these technologies. That's it. Thank you very much for your time.
Fantastic, John. Thank you very much. It says that the autonomous car is going to recover the city for the citizens. But as we can see, we are going to need, or we are working with many kind of different companies working on it. Okay, now we have, it's the turn of Cellnex. You know what? For a journalist to write about Cellnex is always nice, because it's that kind of companies that always have good news. For example, this year, they are breaking all the records in terms of benefits, and I'm talking about a Spanish company. Cellnex deploy infrastructure for telephony, data, and broadcasting for more than 200 million people in Europe. They have, tell me if I'm right, they have 2,000 sites in Europe, and they have 1 million of things connected here in our country, in Spain. They are really involved in the smart cities evolutions and working on connectivity between objects and people, IoT, we say. Efficiency, management, and urban resources. Then please welcome to the panel, Raúl González.
Thank you to be here. I try to explain a different message from now. We have talked about connectivity from Intelsat. We have talked about devices and how these devices can help to change the mobility, the actual mobility. And we talk about transformation, how digital transformation can change the industries and the way that we consume and all the things that we have to it. We have saw in the last years that several industries have changed totally. For example, who remember the music industry where you buy a CD? Now, nobody can buy a CD. You always download your music and you consume your music, you share your music with your friends. And this kind of movement, it's going to the other kind of industrials. We have several examples. One of them is this one. This is some images from Mobile World Congress, where one of the things that we hope, it was cars. There was plenty of cars. More cars than 5G, probably. That it means that it's happening something. Some shift between different industries, some collaboration projects, some new services are growing. And on the top of that, probably, the focus of that is the transformation and disruption of the actual business models and provide more user experience. The experience to drive, it could be changed in the next years. To change this experience, it's necessary several ingredients. Those ingredients are, it doesn't matter the percentage. Infrastructure, it's necessary to have infrastructure. These infrastructures are from different things. There are roads, are petrol stations, are lights, a lot of things. The second one is what we talk, or we call technology enables. It could be exist a lot of technologies, and it's necessary to be easy to access to that technology to develop new services. And this is, the first two are more common, but the other 4 ingredients are crucial to this transformation. You need design services, thinking about the user experience of the people, that it means transform the actual business models, create a collaboration and environment, and at the end of that, create new business models and new services. That's the key to transform this industrial. And that it means that all the things that we know actually, it could be changed in the next years. If we talk about, infrastructure, for example, this is one of the great shifts that we will show it. In some areas, yeah, this shift is a reality. Since now, we built an infrastructure to provide one services to a specific group of people. Now, all the new business model that we have found is provide one infrastructure to be used for several people to several services. That's a great shift. That it means that you need to share what you have in your environment. For example, telecommunication infrastructure. It's only one pipe where the people can build new business models, build new services, and this is one of the key elements that we will show to have a success in a connected car environment. The second one is what we call technology enables. What it means that? That it means that we have data sources that come from different places, cities, citizens, cars, public things, a lot of things, okay? And these things, every day, has more data to transmit, to say how is this element. And use several networks. Use LTE networks, Wi-Fi networks, low power weight area networks, ultra-wideband networks, depending of the kind of element, of the kind of data source, okay? But at the end, what they do is to collect this information in a place where we transform to data. When we have this data is agnostic of the technology that provide this data, and is agnostic to the people that have produced that data. At that moment, it's a neutral element that we can share and we can use to create new services. That's what we saw in some examples. With that data, you can create collaborative applications, social apps, dashboards, new services. When we talk about connected car or autonomous car, you need information from the car, but you need at the same time information from the environment. You need to collect that information in the best way and to be resilient, this collecting of information. Always need to have this information. And with that information, you take decisions. But at the same time, you have an impact with the rest of the environment that you have. When we talk about technology enables, it's a combination between hybrid networks, all the different technologies that we can use, and the data, or how we manage this data and how we share this data. This is, for us, the technology enables. It makes easy to deploy new things. For example, When we talk about IoT networks, for example, is one of the great use case. You have a sensor, you connect it when you power up to a network, and then someone uses the data in several areas. This is a combination between an IoT network plus a platform that transforms this data and make easy to access and to share this information with different people and create new services. That's an example of that. When you combine different technologies, for example, you have different vehicles in different areas. These vehicles can transmit this data using different network technologies. But at the end, you combine them in a data, or you convert them to data and then share to the rest of the people. This is an example of Smart Brain, that it's the platform that we use to collect this information, to anonymize this information, to generate new data, and then to share with another people. There are some examples of that in different areas, because what you need is flexibility. It's the same element that you can use in different environments. You can use for different things. You can reuse this information about mobility to provide new services in the city, but at the same time, the information of the cities, it could be very useful for the cars and for the mobility of the people and how the people are moving or how the people are doing the things. This is one of the pieces that it's important for this digital transformation. But the second one, or one of the pillars, is how we think about the new services. We need to think about more services that sell objects or sell things. That's one of the key points here. And when we talk about service transformation, we need to think about these 5 pieces, which are the insights that the people want, describe and generate new ideas, design these new ideas, collaborating with the different stakeholders, have the greatest scope of the market, develop new services as quick as possible and as easy as possible, and then release these services. This is a change from now. One car manufacturer sell a vehicle, and the responsibility and the use of this service or this vehicle is for the driver. In the next years, we will change that, or could be changed that, to one model where they sell services. The car manufacturers sell services. When they sell services, the responsibility comes for the car manufacturer. That's a big change on that. And the services that are on the top of that could become from the car manufacturer, but could become from another areas. Because when we talk about connected autonomous car, for example, the people that it's driving, it's not driving. It's going with one vehicle, and they need to consume another things, probably contents, books, music, and other services that it could be necessary to make possible in the future. Okay. One of the key points here is collaboration. We don't see connected cars, we don't see this transformation if we don't collaborate with different stakeholders. That's one of the key aspects here. This is an example of that. This is a collaboration project between SEAT, BSM, and Cellnex, where the city provides information that collect from different sensors and the different data that they have to the vehicles through different networks, and with a neutral point that it's called iCity. And at the same time, the vehicle provides information to the city about speed, mobility, where you can find free places, these kind of things. This is a collaboration project where someone provides the other one the information that they didn't have. Okay? It's one of the key points for us. At the end, what we are pushing is to build technology enablers to make possible this connectivity and this transformation. That's the role that Cellnex wants to play in the next years, to build this kind of technology enablers that makes possible this dream to have an autonomous driving, autonomous car, and this kind of new services on the top of that. Thank you.
Thank you very much, Raul. as we have been talking before, it's not the same to share than they collaborate. When we translate that word, we have a lot of mistakes, especially when we write or we talk in Spanish, because we use the same word and we just to make or to have some confusions about it. Well, it's your turn. I want to ask you something. Are you prepared for the autonomous car? Or do you prefer to have a connected car but not autonomous? Well, it's a problem that everybody is asking themselves, I suppose. But, well, now I would like to have your questions. As you can imagine, I am a journalist. I have a lot of questions to do. But I suppose that you want to ask.
Hello, thank you very much for your presentation. My question is about regulation and what kind of constraints do you think that we will have in order for the adoption of this kind of technology? Because at the end of the day, we have a connected car, but it's see that you say, okay, Europe is a more driving, more regulation about the adoption, and it means that we have one constraint, the regulation. It's about regulation, but also it could be about the behaviors. But talking about regulation and how we will need the infrastructure in order to be ready for adopt this kind of technologies is my question to you.
Okay, so when you have an autonomous car, there is a big question of who's driving this car. So you can save 1,000 lives and reduce it to, so you can save 1,000 lives in accidents, but you can have 10. That's fantastic. Everybody would say, yes, I agree. But who is the responsible for those 10? That's the big question. So there is a lot to do. In the technology side, we are working to make it possible. But on the regulation side, there are a lot of things that have to be done in terms of autonomous driving. So European regulation or American. So regulations are very important. In the case of Europe, regulation says that all cars will have to have this emergency call system. It was a very long way, but now we have it. It's very positive. US government is trying to mandate now the V2X technology in all cars to save lives and so on. And we need to make one step more in terms of regulation and liability on this new environment, new way of living. So this is why we need all the players, all the public players, cities, governments, European community. So it's a system job that we have to do all together and in coordination.
If you talk about telecommunications regulation, probably it's more complicated because you need some kind of harmonization with different countries related to the band that you are using and these kind of things. For that reason, when we talk about this kind of connectivity, we talk about the combination of different technologies in each one of the cases. Because if you don't have a clear regulation on one area, you can use another technology that helps you to achieve the same objective. Here in Europe, we have something that it's sometimes go against the evolution. It's the hyper-regulation. That makes difficult to evolve. And probably in this environment, it's necessary to go more to a soft regulation in order to make easy to evolve in this environment.
Thank you. And I adamantly agree with most of those points. Yeah, it's going to take a lot of coordination right now. I think there are, I don't care if you look at Brussels or if you look at London or, Washington, Silicon Valley. There are a lot of folks out there doing a lot of hard thinking with respect to some of this. Most of it will be phased in over time. There's no Big Bang theory with respect to a lot of the regulations that are out there. But I'm a big proponent of believing that we will figure this out. As for the technology itself, the genie's already out of the bottle. We know it can work. Now it's how do we adapt that and how do we introduce it into our daily lives in a way, in a measured way, and also over time that allows us to do that responsibly. But I'm a I'm a big proponent that it'll get done. I think a follow-on question to that might be, it's not only regulation, but there's a big data source out there. There's a lot of privacy concerns also that are being bantered around too. So privacy is also going to play into this in a big way, where you find European privacy regulations are much different than, say, China, which is much different than the United States. So it's a little bit of a three-dimensional problem from that standpoint also.
But Raul, let me ask you something. What about the frequencies? Because is it necessary to have all the frequencies harmonized all around the world?
When we talk about automotive industrial, it's a global industrial. You need to have the same service in different places with different frequency use. At the end, you need to adapt to each one of the regulations in each one of the areas of the world. That's a key point that it's easy to resolve from the technical side, but that's.
Okay, thank you. More questions?
Hi. I would like to ask you about how do you see who's going to control the platform that manages the dashboard in the car? I mean, the infotainment system. How do you see it if it's going to be taken by the mobile operating system providers like Apple and Google, or are the car makers who want to control this? About the openness on this, what's your vision on this? Thank you.
Greg.
It's a great question. I think I explained before that a car company is going from a manufacturing standpoint to a service-oriented standpoint. That which will allow it to make up the revenue that it loses on the manufacturing side, which it will, is going to be from a service standpoint. I think Ford demonstrated recently that while its percentage of revenues that it will receive from building vehicles will go down X percent, it is now entering a bigger pie, which will be the service side of the house. And if they get a smaller percentage of the service, their overall revenues in the next 10 years will be, 30 or 40% bigger. So it's fundamental to their business model that they control that data. I believe that there's going to be different demarcation points. I think that the critical elements that are in the vehicle, powertrain systems, for instance, control of ABS braking, safety services, that which is the industrial side of the vehicle, will be controlled by the OEM, and they're going to want to keep that control. I think it'll then go down into tier ones, and tier ones will be able to pull X amount of data off there too. I think there's going to be give and take between the auto manufacturers and also the tier ones with respect to that. Where the Googles and the Apples and the Microsofts come into this whole thing is going to be on you or I entering the car with our handheld, our tethered device. And it's going to be the application that's on there and who's going to be able to collect that data off it. But I'm highly skeptical that an OEM is going to allow a Google to have access to the operating systems within the vehicle because that's too critical to their business model on a go-forward basis. You might find that a regulation or regulators need to step into that fight and kind of find out where, because I suspect you could actually argue antitrust in some instances where the OEM might want to take too much control. So kind of watch that space too, but for the most part I think the OEMs are going to control the majority of the industrial side.
Well, I fully agree with what you mentioned. Just to comment that it's a matter of control, management, so the OEMs cannot afford anymore that the business is done in their cars to other companies, and they are only the platform. So I put a car for the Googles and Apples keep making more money. So they need to take advantage of this position. They have a very strong brand image, all car makers, and people like their cars, but they want them to be connected. So it's a big balance between control of the OEMs, having part of this business, and allowing the users to keep having the same experience as they have with a mobile phone. So you cannot avoid Apple and Google being in a car, but as OEM, you need to manage all the information, all the interaction with the customer, so you cannot afford not to do that. So that all OEMs are moving this way because it's going to be the key of the business in 5 years.
One more question? No? Okay. The last one for me. Okay. Greg, everybody's talking about the 5G as the most important thing, the enabler of the connected car. But no one used to talk about satellite. And I would like you to explain something about it. And if you can mention Galileo, because we are in Europe, then I would like you to tell us something about Galileo too.
Sure. Let me hit the first one, and I think the slides that my colleague here presented definitely showed that the echo chamber that we hear of 5G right now, of being the next big thing, is going to take time to roll out. LTE is going to be around for a long time right now. I was in Brussels last week and saw some reports that I believe somewhere around 32% of Europe right now is covered by LTE. That leaves a large percentage of population that's not covered, and transportation is going to need to be in all of these areas. So it harks back to that which I talked about as the network of networks. We're going to have to take advantage of all different networks to fuse complete connectivity together. And that's where satellite comes in. Satellite is just another piece of that puzzle. We believe it's a very important piece from the standpoint. We have not been involved in communications from the auto industry that much because there hasn't been any need up until this point, and that's probably why you don't hear about satellite. But I can tell you in maritime and in aeronautical, in a big way, in areas where it's difficult to get to an asset, we control that space in a big way. With respect to Galileo, we're big proponents of Galileo, just from the standpoint, again, of what we've talked about with the integrity of data and security and being able to know physically where you are. Having only one GPS network out there opens you up to risk, number one. Number two, if you have a Galileo network overlaid by a GPS network overlaid by a Beidou network, and also the network in Russia, then you have a more, the picture you get from infinite data flows is much more exact, and being able to then bring that through and broadcast that back out to the asset, be it the car, is in everyone's best interest. So big proponent of Galileo, as well as the other GPS networks that are going into space.
Joan, I have a question for you, because I always hear you to talk about good partnership, but what does it mean in an ecosystem like the self-driving car in which we are working?
Regarding connectivity, there are many pieces of the puzzle. So we need to talk with the satellites, we need to talk with the networks. So you need to talk with the head unit of the car. There are many pieces that all they have to work together in a good way. So you are not alone. You need, let's say, you need to make a puzzle. You need to have the right pieces, but you need to be sure that the puzzle will go on. So you need to select the right technologies. You need to understand the system, and you need to make sure that you are connected with the rest of the players, all as important as the other one. So it's a teamwork as a big companies, big standards. So you need to understand the regulations. If 3G is for example, in US, 3G will be switched off in 2021. So it doesn't make sense that you make a car today in 3G that in 4 years will not work. And it happened last year with the 2G in US. Some car makers had to change their connectivity systems because no more network. So you need to talk with the AT&Ts, with the Vodafones, with the Telefonicas, with the satellite system to understand all communication systems between all parties. So this is one of the complexities of this business, but it's the standard way of doing it.
Is there enough good companies to have good partnership in the world? Because I suppose that everybody wants to be the Apple partnership.
Yeah, it's not a matter of willing to be the good partner. That's a good attitude, but you need to know how to do that. So it's plenty of good partners, and the most important is that we all talk each other and make it possible, like in the mobile industry or in the car industry, the standards, protocols, regulations. So all the ecosystem has to work aligned and with this clear target.
Uh-huh. I think that we have to finish. I'm sorry, because it's nice to talk with you. But okay, it's time for a break. Thank you very much.